So, for this video, we'll be starting basic trigonometry. And trigonometry is the mathematical study of triangles. So, in this video, you'll be dealing solely with triangles. Now, firstly, we're beginning with the trigonometric ratios of a right angled or Pythagorean triangle. Here we have an angle labeled theta, the Greek letter theta, hypotenuse z, and sides x and y. Now there are three main trigonometric ratios which you must remember. They're called sine, cosine, and tangent. Tan and cos for short. Now, if you have an angle theta, then sine of theta is equal to the side opposite to the angle over the hypotenuse. Cosine theta is equal to the side adjacent to the angle over the hypotenuse, and tan theta is equal to the side opposite to the angle over the adjacent. We have a mnemonic device called SOHCAHTOA. So remember this: sine opposite hypotenuse, cos adjacent hypotenuse, tan opposite adjacent. Very simple. SOHCAHTOA can always help you remember it. Now, beyond those, there are a few other trig ratios that are normally not mentioned. There are cosec, short for cosecant, sec, short for secant, and cot, short for cotangent. Cosec theta is equal to 1 upon sine theta, and so it becomes the hypotenuse over the opposite, so z over x. Sec theta is equal to 1 upon cos theta, and so becomes the hypotenuse over the adjacent. Similarly, cot theta equal to 1 upon tan theta, and becomes the adjacent over the opposite. So each one of these is the inverse of these ones. Now we will be dealing with sine and cosine in terms of non-right angled or non-Pythagorean triangles. And the first one we'll be dealing with is the law of sines. Now, here you see we have a triangle that is non-right angled, and we have the angle capital A, capital B, capital C, which will be a capital C, and opposite to them we have sides common C, common A, common B. Now the law of sine says that sine capital A over common A is equal to sine of angle capital B over common B, which is also equal to sine capital C over common C. So basically, if you're given two angles and a side, you could figure out another side. Or if you're given two sides and an angle, you can figure out the other angle, because you could split this up and say that sine A over A equals sine B, or sine B over B equals sine C over C, or sine C over C equal to sine A over A. Do it anyway, and you can just go ahead and solve for which one you might need. Now, the law of cosine is a bit more complex. Now here again I have a triangle ABC, sides ABC. Now for this one, in order to solve, you'll need to have two sides and the angle that comes between, and you would normally be solving for the side opposite to that angle, or you can have the three sides and be solving for the angle itself. What this says is that common B, the side opposite to the angle, is equal to the other two sides squared minus 2 times the other two sides times cos of the angle. So common B squared is equal to C squared plus A squared minus 2 times A times C times cos of B, and if you have the three sides and you want to find angle B, you could transpose 4B, and you could end up with, we can transpose, say, B squared minus C squared minus A squared equal to negative 2AC cos B. Then we could bring this down further, so that B squared minus C squared minus A squared all over negative 2AC equal to cos B. Then we can invert the cos, here that cos inverse of B squared minus C squared minus A squared all over negative 2AC is equal to the angle B.